Hi. What we want to do right now is talk about flowcharts and how they help us design programs. This is going to be really important as you go for your second digital badge about program design and you're dealing with your Hangman program. So what I want to do is just introduce flowcharting to you a little bit, talk about what the symbols mean, and give you a couple examples so that you have something to go on. Please ask me as you're working on your flowchart about any questions that you have, and double check with me that you're doing it correctly so that you don't waste any time. Okay, so take a look at the flowchart that I have in front of you here, and the first thing I want to point out is what's at the bottom of the screen. These four symbols. We've got a rounded oval that says start and end, a parallelogram that says input and output, a rectangle that says procedure, and a diamond that says conditional. These are the main four programming flowchart symbols that we'll be using and that you're going to be concerned with as you write your own flowcharts in this class. So the first one is that rounded oval. That's a terminal symbol. It just means that we're either beginning the program or we're ending the program at that point. And we always represent that either with an oval or, as you see here, I have a rounded rectangle. Secondly, we have the parallelogram, which again means input and output. Anytime you are asking the user for input or you're outputting something back out to them, you want to use that parallelogram to indicate that you are either asking for information or sending back information. The rectangle here is a procedure. This could be something very simple that could be done in maybe one line of code, or it might be a more complicated procedure that you would write a function for. So a lot of times when we see a rectangle, that means we probably want to write a function for it if it's something that's complicated. And then lastly, we have the conditional. Conditionals are if-thens, or also are used in loops, right? So they're items where we're testing to see if something is either true or false. And so that condition is what we're testing, and so we call that a conditional. So the diamond is representing decision points in your flowchart, places where the code might branch or the execution path might branch into multiple different paths depending on the answer to that conditional, whether it's true or false. So what we have in front of us here in this flowchart represents an assignment you've done already, which is testing a number for primeness, determining whether or not a number is prime. And so let's walk through the flowchart a little bit, and hopefully you'll be able to draw parallels to how you implemented that into your code. So we start the program up at the top, and the first thing we do is we get a number, an input. Now in our case, we wrote a function for this is prime, right? And the input was actually one of the parameters. And so in this case, this input is being input as a parameter to your function. Okay, then we have a rectangle that says factor equals 2. Now factor is going to represent the number we're testing against the input num to see if it goes into it evenly or not, right? And so this is a procedure. It's a super simple procedure, right? We're just setting factor equal to 2. One line, very simple. Then we come down to our first decision point, right? Is the factor that we're testing less than or equal to, I should say less than or equal to, it only says less than or equal to the square root of our number. And so, let's see if I can add that in here. So we'll just do this. Less than or equal to the square root of our number. You might have had a different condition. Some of you check to see if the factor was less than the number itself, which also worked, but took a little bit longer. But it's sufficient to check to see if the number is the factor is less than or equal to the square root of our number. Okay, so if the factor is less than or equal to the square root of our number, which in the starting case it is, it's 2, as long as number is larger than 4, or larger than or equal to 4. If that's true, then we want to see if the factor goes into the number evenly, right? And the way we did that was we used the mod operator in Python, right? So if num mod factor was 0, then we realized that the number went into it evenly. This is opposite of what it should be. So if the num mod the factor 0, then we want to say that that number is not prime. That's false. And so we are ending the program. We found a factor that goes into our number, so we're outputting that it's not prime. Is prime is false, and so we're done. But if the num mod the factor does not equal 0, well, we want to keep checking. We want to check all the possible factors up until the square root and including the square root of the number. So we say if it's no, we add 1 to the factor. Again, a simple procedure. Factor equals factor plus 1, one line. But that's a procedure, so we come back and then we check again, right? Is the factor less than or equal to the square root of the number? And now the factor is 3. and we check and see. Eventually we'll get to the point where the factor is either equal to or greater than the square root of our number if it's prime. And so if that happens, the answer here is no, then the factor is not less than or equal to the square root. So we've tested all the possible factors, so our number must be prime. And we end. And so again, we end here with the oval or rounded rectangle. The one thing I want to point out here is that we have an interesting thing happening here. You might notice that this is closed as a loop, right? And so anytime you see a structure like this in a flowchart, that's indicating to you that you probably want to be using a loop when you actually go to program this, right? And so typically we would be writing a flowchart before we try to do any kind of programming. It's to help us design the program and make it easier for us to write the code in a complicated situation. And so we start to see these things happen in our flowchart, and we realize what we have to do programmatically to represent that. And so this is a loop. Great. One last flowchart. I'll do this more quickly. This flowchart represents the second part of your assignment where we had to find the 10,001st prime. And so you can take a look at it. I won't go through the whole thing, but what I do want to point out is one thing here. And if this is the main program, if you will, what I want you to do is realize we had a while loop going on in that assignment where you were checking for the 10,001st prime. We were set a counter variable, and then we were checking values and counting each one, how many of them were prime, and adding one to the counter if we found it was prime, and just adding one to the value either way. And then what we would do is check to see if each of the values were prime, right? So I have a box here for that, a procedure. Now this box is the actual function we just wrote in the last flowchart, right? So everything in the last flowchart was part of this box. And so this is just meant to be an example where you would have a procedure where the implementation of that procedure is actually a function, not just a single line of code. And so just to illustrate that when you go to make your flowchart, for the Hangman game or for any other program for that matter, oftentimes those boxes will represent functions that you want to write. So have at it, and let me know if you need any help with your flowcharting, and make sure you show that to me before you start actually coding. Okay, thanks.